The primary objective of this lesson is to review over some of the graphs we've done, but we also want to introduce a new idea called a piecewise function and how we restrict domains to get there. So it'll just be an introduction to get us to start the idea. So first of all though, we've got our notes down here. We're going to do an opening here. I want you to set up your notes first. We don't have the lines here to separate into two columns. So reminder that this is a two-column note sheet. So we're going to put a line underneath topic and detail across there. And then we're going to put a line going down next to detail here. And all the way down. So just keep it going all the way down past absolute value here. All right, so that's setting up the two-column notes. Now, to take notes on this, what we'll do is we'll start off by having you try this review exercise. These three problems will remind you of a few of the things we've been doing. So try these three, pause the video, do the three problems, and then I'll come back and show you how to do it. So take time now to pause it and do these three problems. Now that you've tried the problems, let's go ahead and go over the solutions. First of all, converting from interval notation to set builder notation, and then going backwards is an idea that we need to make sure we master. So on this is saying interval notation. This is saying the numbers between 1 and 11, not including 1, but including 11. So how we write set builder notation is we start by writing a brace, and then we put an X with a slash, meaning X such that, and then we make the rule for this to say between 1 and 11, so we say X between 11 and 1, but because this is a bracket, it means include that one, so we have to put or equal to on the 11. So this is what we have for our set builder notation. The rule is X is between 1 and 11, including the 11, not including the 1. And then put a brace at the end to show that it's completed. So now we're going to convert this set builder notation into interval notation. So this is formal, X such that. We don't have to worry about that. We just have to know that the rule is X is greater than -6. So we do not want to include -6 because it doesn't have an or equal to, but we do want to keep going on forever. So that means we're going to put an infinity because it's greater than it, and you never get to infinity, so you put a parentheses on it to show that it goes off to infinity. Now this next one you want to use a graphing calculator for in order to look at the domain and range. So let's go ahead, if you, what I'm going to do is sketch it from what we know, go to the graphing calculator to confirm. So just as a sketch of this one from what we know from graphing these, this is saying, remember, that we're going to take our absolute value, which is a V graph. The 3 in front makes it go up steeper, so it makes it go up, stretches it upwards. The -8 moves it over from, instead of a +8, it moves it over a -8 units. So the inside is opposite, but then this moves it down 19 units. So I'm going to start at +8 out here and down to -19. And I'm going to put the vertex of my V, and then it's going to stretch it up and go up fast. This is just a quick sketch of what that graph would look like. Now let's look at the graphing calculator to confirm. So now we're going to enter it in. So if you turn on your graphing calculator, go to the Y equals key here in the top corner. Remember, if you have something in the Y equals, you go ahead and hit clear to erase whatever's there. Now I'm going to enter in this equation. So we're going to take 3, and you could put times if you want to. You don't have to. If you leave it just 3 with an absolute value next to it, the calculator knows it's multiplication between those two. Now where you find the absolute value, you've got to go to your math menu, go over to hit the right arrow here to go to under number, that number menu, and then absolute value, that's your first one there. ABS stands for absolute value, and then absolute value pops up for me. Inside the absolute value, I want to put an X, so there's X, the X key there. Minus is over here, 8. Now I want to get out of the absolute value, so you hit the right arrow to get outside of it, and then we're going to put the minus 19. Now if you hit graph for this, what happens is, oh, it looks like we made some changes to our window on the graph before, so we want to get a standard look for our window. You hit zoom, and you go down to standard. That will give you that standard -10 to 10 graph window where it goes from x's from -10 to 10 and y from -10 to 10. Now I don't see the entire V, and that's because notice that this goes below -10. So what we should do is we should change our window. We're going to change that window, and I'm going to go ahead and go below -19. So let's go ahead and change the y minimum down to maybe let's say 25. It's really your choice, but I just want to go further down below it. Let's do the x's, since 8 is where this cuts off here for the vertex. Let's go over maybe up to this maximum, maybe make that up to a 15 in order to see the whole entire graph. And then when I hit graph, that fits in the window a little bit better where I can see that V. And just a reminder for on your calculator, you can hit second table, and you can get table values, and you can go ahead and, looks like I'm very large numbers here, so I'm going to go ahead, those are the negatives, notice, and I can go from all these negatives and come back down and get to some positives. Notice that it changes direction to go back positive. It bounces there at 8. If you notice there at 8, it changes from going down to going back up again. So that's what the graph looks like. Let's do our domain and range. So the domain of this, I'm going to abbreviate as just a D here. The domain will be every x value, because notice that these keep getting wider and wider. As it goes up, it goes wider on both sides, up and wider. So how we represent all real numbers is we put a parentheses and put -infinity to infinity. That means, I'm going to put down here, all real numbers as part of that. Now, the range, on the other hand, is going to be, it only goes down to -19. So my range is going to be include -19 because it does include that y value, and then it goes up and up and up and up further off to infinity. So my range is off to infinity. We put a parentheses on the infinity. All right. Now, last thing it says here, let's use this function notation. Find f of -4. That means you substitute -4 in for x. So 3 times the absolute value, we get -4 minus 8, absolute value, minus 19. Now let's go ahead and do some calculations. -4 minus 8 is -12. -12, the absolute value of it is +12. Absolute value turns negatives into positives. It leaves positives and 0 alone. Minus 19. And then if you're not sure how to do that calculation again, just pull up your calculator. And once you have it, we can go to the calculator screen. I'm on this screen, and if you hit second quit, that will bring up the calculator screen. I can do 3 times 12, and then subtract 19. And that gives me a value of 17 for it. All right, so now this is the review you have. Let's go ahead and do a little bit of a graphing review for us. Okay, so graphing review here, we want to go ahead and put in some formulas here to graph a line. We're going to start with just f of x equals first one I'm going to do, just f of x equals 2/5 x plus 3. Now, a reminder, you can put that in your graphing calculator and do it, but I can do this by hand. Just a reminder of how this looks. This is the slope of the graph, and this is the y-intercept. You might remember that from your from doing this in algebra and maybe a review in geometry. So I'm going to start at the y-intercept. I start at the 3 here, and I'm going to go up to 1, 2, and over 5. 1, 2, 3, 4, 5. Up to 1, 2, over 1, 2, 3, 4, 5. And then I draw a line through those. Okay, so this is, my slope is rise over run. Okay, so that's what that means. And then this y-intercept is where it crosses the y-axis. So day one, we talked about those intercepts. And that's where it crosses an axis. Okay, so slope is my rise over run, tells me how far up and how far over it goes. Another, let's do a domain and range on that one real quick. So the domain for this, notice it keeps going as to the right as far as forever, and to the left as far as forever. So the domain is going to be negative infinity to infinity. And the range, it keeps going up and it keeps going down. So the range is also all real numbers, negative infinity to infinity. Now I do want to do one more graph for us. And I want to make sure that we remember our horizontal lines. If I want to do a different function, say g of x equal to, let's say, negative 4, g of x equal to negative 4, otherwise known, you've sometimes seen as just y equals negative 4. When I have function notation, it means the same as y equals. Remember that is a horizontal line. So y equals negative 4 just is a line like this, straight across at negative 4, horizontal. Now let's talk about its domain and range. Okay, the domain and range for this has to do with looking at the x and y's. Now if you look at the x's, it still goes forever in the positive direction, forever in the in the negative direction. So that means we're going to have negative infinity to infinity. But when you look at the y values, it doesn't go up and down, it stays at negative 4. So this graph, the only value that it is, the range value is just y equals negative 4. Okay, so you can just list it as that. You could put it in set builder notation if you want to, with y such that y is just equal to negative 4. It's not between anything, and that's what interval notation is usually used for. All right, let's go down to parabolas. Let's review over a parabola graph. Okay, a parabola graph, for instance, we might try f of x equal to x squared plus 7. So x squared plus 7, what you want to do is either put in your graphing calculator, but we know this is going to be a u, and it's going to go up and down. The general look of a parabola is f of x equals a times x minus h quantity squared plus k. And if you remember this number here, what it does is it will, first of all, if it's negative, it will flip it. And if it's a different number, like a 7 or a 9 or a negative 3, it will also stretch it vertically. If it's a fraction, it'll make it wider. If it's an integer, it'll make it go up faster, down faster. This number here This is how far we move side to side. And then this number here, that's going to move it up or down. All right, so when we look at this graph, what we do is we're gonna, if we were to set up a table here and look at a table, let's go ahead and put it in our graphing calculator, see what we got here. All right, so we're gonna go to our, turn it on here, go to y equals, we're gonna clear out the previous one, and I'm gonna put in x, here's my x, and square it, I'm gonna put plus 7, and then I'm going to go ahead and look at my table. My table, and I'm going to have my table around 0 here. So notice I've got several values. I've got -1 goes with 8, -2 with 11, -2 with 11, -1 with 8, 0 goes with 7, and then notice it repeats here. The interesting thing about parabolas is at 1 it's going to be 8 and 2 at 11, so it repeats values. It's called symmetry that we'll talk about on a later lesson. So we've got 1 with 8 and 2 with 11. So if we plot those points, -2 up to 11, -1 up to 8, 0 with 7, 1 with 8 and 2 with 11, you get the parabola look. The U shape to it. Now absolute value follows a similar pattern, only it's a V shape for it. And so for my equation for absolute value, you're going to have something very similar, A times absolute value of x minus h plus k. And these things have the same properties. The A in front will flip or stretch. The h in the middle will move side to side, and we're going to put the word opposite here, because remember on the inside it moves in the opposite direction. And then the k out here, let's change that, the k will move it up or down. All right, so let's do an absolute value graph. So we're going to do, let's do h of x, we can use different letters for our functions. H of x is equal to, let's do let's do a -2 times the absolute value of x minus 1 and then plus 3. Now this minus 1 is going to move it over 1 unit, the plus 3 will move it up 3 units, and this -2 will flip it over and stretch it down. So let's go ahead and set up a table for that. And we'll look at our graphing calculator to help us out. So we can go to y equals here, clear off my previous graph, put in a -2, use this as the opposite, -2, and then you can put it times, you don't have to, so math, go over to number for absolute value, and hit enter, there's my absolute value. Let's do x minus 1, x minus 1, and then I want to get outside the absolute value, so I'm going to hit an arrow over, and I'll put a plus 3. Now, let's look at the graph here. So the graph of this, I'm going to do a zoom and then go down to standard to get my standard graph because I changed the window before. And I've got a -10 to 10 here. Notice it flipped it upside down. So if I look at my table I'm going to center around that point. Notice I said it's going to move it over 1 and up 3. So that point right there, I'm going to say 1, 3 is going to be in the middle of my table for this so that I can see what happens around it. So if you look 1, 3, I got 0, 1, -1, -1, 0, 1, -1, -1. And then it repeats over on the other side. Like 2, I'll get a -1. Excuse me, 2, I get a +1. And then 3, I'll get a -1 because it has that repeating pattern on both sides of that where it moved it side to side and up and down. Okay, so notice I've got my 2, 1, 3, -1. Let's plot those points. So -1, -1, 0, 1, and so it's gonna go down like this. And then I've got 2, 1, and 3, -1, and it goes down like that for that. So there's a review of our different graphs and how you can use your graphing calculator to help you with those and how it affects it. Let's go ahead to the second page of your notes. Okay, so on this, what we're going to do is we're going to do a restriction on these two. I'm going to graph this one, and then I'm going to restrict it. Graph this one, and then restrict it. So first of all, to graph 2x minus 3, let's go ahead and I'm going to do this one in red. Okay, now let's start at -3, 1, 2, 3. And then remember my slope, this is my rise over run. Try that again. Rise over run. So rise over run is going to be, in this case, 2 over 1. So we go up 2 over 1, up 2 over 1, up 2 over 1. And then you draw the graph. Now, this says I'm going to have a restricted domain. So I take that graph, and what I want to do is stop it at the 2. So let me draw a quick version of this graph. Don't draw the graph yet, but what I'm going to do is I'm going to just say, okay, if I started at -3, I went up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and then drew the graph. What this restricted domain is, it basically is telling us, stop the graph at the 2. So I'm going to stop it right there at that 2 and use only that part of my graph. So this is how you restrict a domain, is you only do the part that it tells you. I'm not using any x values less than 2. All right, so same graph as that, just stopped and the rest of that has been erased. Okay, let's do this one now. Let's do x squared plus 3. Just a reminder of what that looks like. Let's see if I can get it to work with red this time. Okay, so with this, I'm going to go with x squared plus 3. I'm going to start up here at 3, my graph. And if you want to, you can put it in a graphing calculator. But what this one will look like is it'll be at 1, 4. If you put in 2, 2 squared is 4, plus 3 is 7. So it'll be 2 up to 7. And so it'll look like this. And then it will repeat it right over here, okay, for the graph. Now, if I want this restricted domain then, let's go ahead and repeat that graph over here in red. Don't draw it yet because we're going to restrict the domain. Start it up here at 3. And then it's going to go, if you put in 1, it's going to equal 4. -1 will be equal to 4. If you put in 2, you'll get 2 squared is 4 plus 3 is 7. So up to 7. Same with -2 squared is a positive 4 plus 3 is equal to 7. And so when we look at this graph here, what we want to do is restrict the domain to less than 2. So I'm going to take this and I'm going to erase everything on this graph that's greater than 2. Okay, and I'm going to get rid of this one here and just make it an open dot there because it's going to be less than it. So these are all the x values that are less than 2. So if I want to do what's called a piecewise function, so if I want to do a piecewise function, fill this in here, where the rule is 2x minus 3 for x is greater than or equal to 2. Notice that was what we did up here at 2x minus 3 greater than or equal to 2. And if I want to do the second part of the piecewise function, the second rule, so you have 2 pieces to it, x squared plus 3 for x is less than 2, this just tells me use this rule when our x values are less than or equal to 2, use this rule when the x values are less than 2, so greater than or equal to, less than 2. So I get my 2x minus 3, and it was a closed dot there. I'm going to go with this here. Okay, so, and what I'll do is I'll take this and go from here, just this part of the graph, and go up from there, to greater than or equal to 2, and I will erase the rest of it. I don't want this side of 2. And then I'll do the same thing with, this one. I'll start it at 3 here for my typical graph. I'll go up to 4, and then I'll go up to 7 here when I get to 2, but I'll do an open dot like I did there, and then do the same thing on the other side, but I'll keep it going. So this graph will be a parabola that goes like, oh, this one's going to be right there. It'll go like that. And so a piecewise function has this interesting look where it ends up looking like 2 pieces on the same graph. This line here goes off to forever on 2, and this part of the parabola. So piecewise functions do your normal graphs, but then just use only these domains for those. Only use the x values that are listed in the domains here for these rules. So we've reviewed over your typical graphs that we have early here in Algebra 2, and then we've talked about extending that a little bit, restricting our domains so that we now have what are the beginnings of looking at piecewise functions.